Assalamualaikum and good evening. I am Siti Roshikin from 2BFT. We represent to you my team video assignment. This is our dynamic assignment for project motion. My team and I decide to choose basketball shoot for this assignment video. So this is my team member, which are Muhammad Hakimi, Siti Roshikin, which is myself, and Muhammad Daniel. Okay, so projectile motion is an object thrown or project into the air, subject to only acceleration of gravity. The object is called projectile and the path is called trajectory. The motion of falling object for one-dimensional kinematic is so simple, but in this case we use two-dimensional projectile motion. We use basketball to present our projectile motion in this project. This is because in basketball, the ball is thrown to the air and the speed plus acceleration is depend on the gravity, which is same as the definition of projectile motion. The ball is thrown in three different angles. We shoot a video of this project and use tracker video analysis to simulate the data and analyze the motion of the ball. Okay, this slide shows the way to ensure the data will be in good quality. First, good video quality for software to detect, which means we cannot put blurry video in the software. Second, use a high contrast background to make the tracker easy to read the motion of the ball. Third, for each angle we throw the ball for 3 times to get the accurate and average reading of data. Fourth, the weight and the shape of the ball is constant for every angle that we use. 5. No external force is exerted to the ball. The data may have been affected overall by first one, surface friction on the court. Second, starting point for shooting may be different. Third, windy day cause the difference in path of the ball motion. Fourth, human error way of throwing the ball may be different. Okay, so this projectile motion can be resolved to horizontal, exponent, vertical, and also y component. So these are the equation that we can use to solve this projectile motion. So we got first equation. The second equation is actually the simple form for equation 1. And same goes to equation 3 and equation 4. Equation 4 we will get from equation 3, which you take y naught to the other side and got minus, and then we got the delta y. So we got the equation 4. So same goes with equation 2, which means from equation 1 we put x naught to the other side and we get the difference of delta x. So this is our first angle. We use 75 degree. Okay. Right. So as we can see, this red dot is our path of the ball, path of the projectile motion. Okay. Okay, so this is result from the tracker. We got graph x position versus time. So we got linear, which is the equation for the graph. And this is graph y position versus time. We got parabolic graph, and for x position versus time we use equation 2 to get vx naught. Meanwhile for y position versus time we use equation 4 to get vy naught. For this angle graph vx versus t will obtain like this. Normally for projectile motion graph vx versus time is always constant, but for some reason we obtain like this, which means we have some error in our projectile motion. For Vy versus time graph, we obtain like this, which indicate the velocity decelerate in y component.
This is our second angle simulation using tracker software. Based on the data in the tracker software, we compute a XT graph and VY graph. For XT graph, the graph increases linearly because displacement increasing with time. And for YT graph, the graph is polynomially because the ball travels in projectile motion at Y component. We also can get delta x and delta y using equation 2 and equation 4. Tracker software also give data Vx and Vy. The slope of graph Vxt supposedly constant. And for Vyt, the slope represents deceleration because gravity pulling the ball downward. D is our last angle, which is the third simulation using tracker software. From the data given, graph xt increasing linearly because displacement increase with time. And the graph yt is polynomial because the ball travel in projectile motion at y component. For graph Vxt, the slope of the graph supposedly constant. And for graph Vyt, the slope represents deceleration because gravity pulling the ball downward.
Now we look at this graph. This graph is where we compare x position versus time. The orange graph represents the 75-degree angle, the red graph represents 50-degree angle, and the last graph represents 43-degree angle. This is the linear equation of the graph. So this equation is for this graph, this equation is for this graph, and this equation is for this graph. From the graph, we can conclude that increase in angle lead to decrease in x component. Next, we want to look at y position versus time. For this graph, we want to compare the peak of each graph to each other. As shown here, we can conclude that the angle affects the maximum peak of the graph. As the angle increases, the higher the peak of the graph that we got. This is the polynomial equation for each graph, as you can see. Next, for the graph for Vx versus time, supposedly we get constants for Vx versus time, and this is what we got from the comparing graph. Each graph for different angle is the same. Therefore, for this graph, the point at the end of motion is the same although the angle increase. Now let us look at this table. This table has value that we got from software analysis. The only value that we got through calculation is Vx naught and Vy naught. For Vx naught, we use equation 1, which is x equal to x naught plus Vx naught times t. And Vy naught, we use equation 3, which is y equal to y naught plus Vy naught times t plus half Ayt square. After substitute the value of x, x naught, and t, we can get the Vx naught same as the Vy naught. After we substitute the value of y, y naught, half Ayt square, we can get the Vy naught. Now for the conclusion, our team conclude that based on the data collected, estimation of percentage error that we got is 8%. This error occurs because of external force from surrounding. Thus, the data can be accepted as percentage error is below 10%. That's all from us. Thank you for watching and have a nice day.